Welcome to The Explainer. Today, we're cracking open a massive, literally planetary-scale puzzle presented in a framework known as the Unified Theory of Geologic History, or UTGH. Based on source documents compiled by author Darrell Waters, this theory makes some absolutely staggering mathematical and astronomical claims about our planet's ancient history. We're going to examine a pretty wild proposition today, the idea that Earth literally lost a massive chunk of its deep interior material thousands of years ago, and that we can actually track exactly where it went.
Okay, let's dive into this. The source text proposes that roughly 5,300 years ago, a catastrophic geological rupture caused the Earth's radius to physically shrink by about 46 kilometers. Now think about that for a second. If an entire planet shrinks, the volume it loses doesn't just vanish into thin air, right? That mass has to go somewhere. So, we are essentially looking at a planet-sized missing persons report. Where did all of that material go?
To really wrap our heads around the sheer scale of this mystery, we have to look at the math. The UTGH framework calculates that the mass evacuated from Earth was an astonishing 10 to the 22nd power kilograms. That is a 10 with 22 zeros behind it. We're talking about a volume of material so unimaginably heavy that it fundamentally altered the planet's rotation when it departed. According to the text, this staggering amount of mass permanently escaped Earth's gravitational pull during one single cataclysmic event.
Section 1. The Planetary Ejection Mechanism.
So how exactly do you launch that much stuff into space? Well, the text points to a very specific state of matter known as supercritical water. The framework argues that deep beneath the pre-flood Earth's crust, there existed a global underground ocean. But this wasn't an ocean like we think of today. Because it was trapped miles beneath solid granite, it was subjected to extreme temperatures well over 374 degrees Celsius and crushing pressures over 40,000 atmospheres. Under those extreme conditions, the distinction between liquid water and gas just completely disappears. It becomes supercritical. It's a highly pressurized, volatile fluid that stores enormous mechanical energy. You can kind of think of it like a planetary-scale spring completely compressed, just waiting to snap.
When the Earth's crust finally fractured, the result wasn't just some slow leak. It was instantaneous decompression. The supercritical water, carrying massive amounts of pulverized rock and mantle material, was expelled violently upward. Because it was transitioning from extreme deep Earth pressure to surface pressure instantly, it acted exactly like a detonation. The source calculations indicate this material ejected at speeds between 47 and 93 kilometers per second. For a little context, Earth's escape velocity is only about 11.2 kilometers per second, so this means the material was moving 4 to 8 times faster than what's needed to leave Earth entirely. This wasn't just a terrestrial flood, it was an explosive solar system event.
Now, to be clear on where this sits compared to mainstream science, the standard uniformitarian view proposes that the water we find scattered on other planets and moons was delivered slowly, mostly via cometary impacts over billions of years of deep time. The UTGH catastrophist framework, on the other hand, proposes the exact opposite. It argues that a massive volume of the inner solar system's water was actually delivered rapidly, in a single, highly energetic event, radiating outward from Earth.
Section 2. Tracking the solar inventory.
Now, what's really interesting about this perspective is that we're basically stepping into the shoes of cosmic detectives. The author of the UTHGA text summarizes this perfectly, saying, "The solar system is not a mystery, it is a crime scene." That quote really hits the nail on the head. We aren't just looking at random disconnected collections of space rocks and ice anymore, we are actively tracking the scattered forensic debris of Earth's own missing interior.
So where is all this missing rock and water hiding? The text rapidly lists several specific celestial bodies where Earth's evacuated material can allegedly be found today. This includes the bright pulverized regolith on the near side of our moon, the polar ice caps and subsurface permafrost of Mars, the hydrated rocks in the asteroid belt, the massive subsurface ocean of Jupiter's moon Europa, and even the young water ice making up Saturn's rings and its venting moon Enceladus.
Just to give you a sense of the sheer incomprehensible scale we're talking about here, let's look at just one of those locations, Jupiter's moon Europa. According to the data cited in the text, Europa's subsurface liquid water ocean holds 2 to 3 times the volume of all of Earth's modern surface oceans combined. The UTGH proposes that this massive volume of water is actually Earth's former underground ocean, captured by Europa as it sat directly in the path of the high-velocity ejecta.
But hold on, how do you actually prove a connection like that? How do we know it's Earth's water? Well, the framework points to a chemical isotopic fingerprint known as the deuterium to hydrogen, or DRH ratio. This ratio perfectly reflects the specific temperature and pressure conditions under which water was formed or held in equilibrium over long periods. Subcrustal water from Earth has a very specific DRH signature that is entirely distinct from primordial space water. By acting as a forensic tool, this isotopic fingerprint can theoretically link the water on distant moons and comets directly back to Earth's deep crust.
And this brilliantly illustrates the point when we look at the composition of the asteroid belt. Roughly 75% of the belt consists of dark, carbonaceous C-type and D-type asteroids. Now, these bodies carry about 10% water by mass, but more importantly, the source text notes that roughly half of these water-bearing asteroids show D/H ratios that perfectly match Earth's ocean water, rather than the primary solar nebula. So, according to the UTGH, this massive reservoir of water is sitting right there in the asteroid belt, basically wearing an Earth isotopic name tag.
Section 3. Balancing the cosmic ledger.
All right, here is where it all comes together. We have the mechanism, we have the suspects, and we have the forensic fingerprint. Let's balance the final mass ledger, as calculated by the UTGH framework. In column A, we have the calculated input, the mass loss from Earth's interior when its radius shrank, totaling 10 to the 22nd kilograms. In column B, we have the output, the conservative inventory of water and material mapped across the Moon, Mars, Europa, the asteroid belt, and Saturn's rings. And the total integrated mass found across the solar system? Approximately 10 to the 22nd kilograms. The ledger perfectly aligns. The mass evacuated from Earth matches the conservative tally found across the solar system.
And it is super important to point out how the text views this alignment. This balanced ledger represents a conservative floor, not a ceiling. Because the ejecto was launched at 4 to 8 times escape velocity, an unmeasured fraction of that mass undoubtedly drifted permanently into the void between stars, lost forever. The fact that the recoverable fraction alone closes the equation makes the mathematical convergence even more robust. You know, you can't artificially tune a minimum floor convergence. It closes cleanly purely based on the physical data we currently have.
We've explored a truly remarkable thought experiment today, tracing an unimaginable volume of missing mass from deep within our own Earth all the way to the frozen rings of Saturn. If the math truly converges, and if the isotopic fingerprints on these distant bodies match our own planet's deep crust, well, what does that mean for our understanding of the solar system's history? It challenges us to look up at the night sky not as a static painting of slow evolution, but as the scattered, dynamic aftermath of a planetary cataclysm. It's a fascinating perspective for sure, and one that absolutely leaves us with a lot to question and a whole lot more to explore.